When you use a login with Google or Facebook button to access a new app, you are essentially inviting a third party to shadow your movements. To get the convenience of a single sign-on, you've historically surrendered your cross-site tracking data. The Anonymous Self-Credential Framework, or ASC, breaks this dependency. It allows you to maintain a single Sybil-resistant master identity that generates unique, unlinkable child accounts for every separate application you use. To implement this system, you will need the U2SSO command line tool, an Ethereum testnet wallet for registration fees, and a secure local directory to store your credentials. By the end of the setup, you'll authenticate across platforms using your self-issued credentials rather than a corporate identity provider. We'll start by creating the root of your identity. Run the CLI create command, supplying your Ethereum private key and a path to save your local credentials. The terminal output confirms your identity is recorded on the smart contract. This one-time transaction places your master identity into the registry. The numeric array displayed is your passkey, required to derive your service-specific accounts later. It is vital that you secure the key1.txt file created in this step. Because this system is decentralized, losing this local file means there is no forgot password link. You would lose access to every account tied to this master identity. Conceptually, your identity is no longer an isolated entry in a corporate database. You are now part of an anonymity set, meaning your master identity is hidden among a group of other valid users on the public registry. To register with a new service, like Website A, navigate to their sign-up page. The site will present you with a challenge, a unique string of text used to verify your request. Copy that string and use the CLI proof command. You'll need to provide the challenge string and the pseudonym you've chosen for this specific site. This triggers a zero-knowledge proof. The CLI uses your master credential to prove you are a valid member of the registry without actually revealing which master identity belongs to you. Finally, copy the resulting proof and nullifier from your terminal and paste into Website A's registration form. Website A has now verified you as a unique, legitimate user, but it hasn't acquired a single piece of trackable personal information. Once you're registered, the daily login process is even faster. On Website A's login page, you'll be given a new challenge string. Copy this challenge into the CLI's login command. This will generate a mathematical signature that confirms your ownership of the account. Crucially, this login step happens entirely off-chain. Because you've already registered on the registry, these daily authentications require no blockchain interaction and no gas fees. Paste the signature back into the website, and you're in. You've achieved a same streamlined flow as a traditional single sign-on, but the authentication is now entirely user-initiated and managed from your local machine. The real power of the system becomes clear when you add a second service. Open Website B and follow the same registration process we just completed for Website A. Comparing terminal outputs, the nullifier strings are completely distinct. Website A sees one sequence, Website B sees another. This is multi-verifier unlinkability. Even if colluding, these sites have no mathematical way to link the accounts to the same user. However, if you attempt to create a second account on Website A using that same master identity, the system will generate the exact same nullifier as before, and the site will reject the duplicate. This Sybil resistance ensures that while you remain anonymous, you cannot abuse the service by creating an unlimited number of identities. It balances the user's need for privacy with the service provider's need to prevent bot-driven manipulation. We are seeing the infrastructure of digital identity move away from central silos and towards distributed, user-controlled nodes. Throughout this process, you have successfully accessed two separate platforms using one master identity, without leaving a trace of your activity for a central provider to collect. By managing a single root credential locally, you've removed the need to rely on data mining monopolies for your digital access. For those building the next generation of web services, the U2SSO documentation provides the roadmap to integrate this framework and secure your users' digital sovereignty.